to look at how to write those equations. Okay, so my blank notes are in the folder for you to follow along if you like. We are in the day 4 or 5 folder today, and I'm going to start the writing transformation notes. It's really just a lot of practice today. It will not take anywhere near as long as me using all 48 minutes on Monday. I'm going to do an example, let you guys try some examples, and then show you some correct answers after that. Okay. So topic 2's goal, writing transformations of parent functions. Okay. Before I go into this, I'm going to give just a little recap, summary of the different things that we talked about Monday, Tuesday. Maybe write it in a different way. Maybe you will like, maybe you'll like the way this looks today better than it clicked earlier. So we have translations. And when I say translation, that's when we're talking about left, right, up, and down. Those translations look to us in 2 forms. I think I used actually a C in the notes. I'll be consistent about that. F of x plus C, f of x minus C, f of x plus C, and f of x minus C. So depending on whether that transformation happened outside of the function or inside the walls of the function, makes a difference to whether that plus means up or whether that plus means left. When it's a minus, we have down, or when it's inside, we have right. And the whole inside-outside thing is outside is all vertical, and inside transformations will all affect the shape of the graph in the horizontal direction. So we had translations, left, right, up, and down. The next thing we had were reflections. And reflections could be in the horizontal direction when we reflect side to side, and reflections could be in the up and down direction, like happy and sad parabola. All of the reflections related to a negative sign in the problem, and it depended on, again, whether that negative sign was inside the parentheses or in front of the parentheses. So whether you had negative square root of x or the square root of negative x. When it was in front, we call that one an x-axis reflection. Some people like to call it a vertical reflection. Either one is fine, but it is a reflection. And when it is inside, we end up with a y-axis reflection, or again, you can just call that a horizontal reflection. So translations and reflections usually are the 2 that people have the most initial success with. And the one that takes a little bit of practice to get good at is the stretches and the compressions. And I'm just adding a little space here because I want to remind you that stretching is when something gets bigger. Maybe I should write this underneath so I have room. I was going to say bigger, taller, or wider, depending on what kind of word syncs with you. But one thing I noticed yesterday when doing the pair deck is some of us were having trouble with picking the word stretch or the word compression. So I want to add that to our notes today. And a compression is when something gets smaller, or maybe shorter, or maybe you like the word skinnier. Okay, because one thing I noticed yesterday is that we had a couple of problems where we were left to choose between like a vertical stretch by 2 versus a vertical compression by 2. And whether it was just digital learning or not understanding, you know, it's hard for me to know when I don't have you guys in the room, but we seem to not, some of us not make that connection that if you're multiplying by 2, that multiplying by 2 is going to make something bigger. So we should call it a stretch and not call it a compression. So maybe adding those words will help some of you who were struggling with that. Okay, so stretches and compressions all had to do with multiplication of numbers. So whether we were multiplying in front like 2 times the absolute value of x, or whether we were multiplying inside, like the absolute value of 2x. Okay. And what made the difference between the two, what made one graph be a stretch and one graph be a compression, was what size was that A? So in this case, when A was bigger than 1, then we had a vertical stretch by A. When A was between 0 and 1, then we ended up with a vertical compression by a factor of A. Okay, so I did that one first because that one's like the straightforward one. Everything we do vertically is kind of like common sense. Multiply by 2 gets twice as big. The horizontal stuff's got the little bit of a mind switch to it. So the stretch, when it is a stretch, you actually end up stretching or compressing by the reciprocal amount. So instead of saying by A over here, we are going to have by 1 over A. And again, 1 over A is just a mathematical way to say reciprocal. Remember, reciprocal is when 2/3 becomes 3/2 or 5 becomes 1/5. Okay, so the amount in a horizontal stretch or compression will always be the reciprocal of the number you see being multiplied. Okay, and then I'm going to switch this part because we're taking the reciprocal. I don't need to write by again. I apologize. Since we're taking the reciprocal, the stretches happen when A is between 0 and 1, and the compressions happen when A is greater than 1. So when we see in an equation, for an example, I'm going to do absolute value. We see the absolute value of 2/3 x. So the first thing we're going to do with that is go, okay, that 2/3 is inside those absolute value bars. So it looks most like this. It's a multiplication and it's inside the parentheses. Okay, now I'm going to look at the actual value there, the 2/3, and see where that falls. Is 2/3 between 0 and 1, or is 2/3 greater than 1? Well, 2/3 is between 0 and 1. So that tells me that I am going to have a stretch by the reciprocal of the number in the equation. So this would be classified as a horizontal stretch by 3/2. And today what we're going to do is go backwards from that. And I'm not going to jump right into stretches and compressions. I'm going to start this with reflections. And when I start with the stretches and compressions, I'm going to make them vertical. But what we're going to do today is take problems like this, where I tell you a parent function, I tell you which equation I want you to use, and I tell you what do I want you to do with it. So here's my first example for today's notes. And it really is just a bunch of examples today. There's not rules. There's not any like definitions to write down. We already did all of that. So for this, it's really just going to be me showing you a bunch of different examples, and hopefully seeing those examples with different parent functions will kind of give you a foundation to use moving forward. So I want to put left 2 in all 3 of these functions. So maybe some of you are already on top of this and you've got this, but I'm going to walk through this like I'm still kind of grasping my hands around it and I'm still not super confident. So I'm going to come to my notes and I'm going to find where I wrote left as a direction. So I'm seeing that I identified left here, and the key feature of a left was that I was going to use a plus sign by however much I wanted to go left, and I was going to put that plus sign inside the function. Now, sometimes that's easier than others. So for example, here with 1 over x, when I put the plus sign in the function, it looks like this. It becomes 1 over x plus 2. The plus 2 went inside. It went under with the x exactly. When it goes inside the absolute value, it just goes right inside the bars of the absolute value. Sometimes we have to add parentheses to put something inside. And that would be the case of like x squared and x cubed. If I want to put left 2 inside that function, I want x plus 2 to be squared. Because when something is inside, that parent function is being applied to it. So those are all 3 different examples of left 2. So now I'm going to make them all left 2 and up 3. Oh, no, you know what? Let's do it separate. We'll put them together after we put them separate. Let's do up 3 separate. So again, let me walk through it like I'm still not super confident. I want to see my notes. Let's go back to where we see up. Up's right here. Up shows up as a plus sign, and that plus sign shows up outside the parentheses of that function. So if I want to move x squared up 3, then that 3 is not going to be squared. In a reciprocal function, it means it's not going to be attached to the reciprocal part. In an absolute value function, it means it's not going to have the absolute value applied to it. So that would be x plus 2 quantity squared versus x squared plus 3. And there you can see the difference between inside and outside in 3 different functions. And if I put them both together and I say do left 2 and up 3, then I get x plus 2 squared plus 3. That's got both of them. I get 1 over x plus 2, and then the plus 3 after the reciprocal part. And if I put these 2 together, then I get x plus 2 on the inside and plus 3 outside. And that gives me both of those pieces combined. So my goal with today's was just to show you a couple of different examples and kind of ease our way into working with horizontal stretches or compressions, because those are the ones that trip people up the most. So here on my next example, we're going to try to put all of them together at once. We're going to do x cubed first, and then I'm going to do log x with the same thing. So we've got x cubed. We want vertical stretch by 2. We want reflection over the y-axis. And we want right 4. And we're going to jump right to, we're going to put all 3 of these in the equation at the same time. Okay. So I'm going to go back a slide to check out vertical stretch by 2 and see what we said about that. So here's my vertical. Vertical stretch is right here. So we see where those 2 match up, vertical stretch by 2. So that shows me I'm going to multiply in front of the equation by the number I want it to stretch by. I want it to stretch by 2. I'm going to put a 2 there. So back to that. In front of the equation tells me I don't need to add parentheses. If I add parentheses, now I've put it inside. So I don't want those parentheses there. It is being multiplied in front of or outside. It's not getting cubed. Okay, now we want a reflection across the y-axis. Let's come back to our summary here. Reflection, y-axis reflection shows me that the negative sign is supposed to show up inside the function. This might be one where we need to add some parentheses here. So I'm going to have to put the negative sign getting cubed. That's a reflection across the y-axis. And let's throw back in the vertical stretch. Remember, our goal is to put all 3 of them together, kind of doing it one at a time. All right, now we also have to make it go right 4. All right, so let's go back. Right 4. The negative sign is also going inside the parentheses in order to get that to happen. All right, so an intentional example here. And when you have multiple things happening on the inside, maybe this is one place today where I'm going to add a little bit of notes to it. They need to be identified separately. Okay, so I'm going to make a little note of that. when we have multiple, and this is only going to be on your inside, because when it's outside, you're usually putting something in front and something behind, and it's easy to put them together. But when you have multiple inside or horizontal transformations, separate them with parentheses. So when I put the right 4 inside that, I added this set of parentheses here so that I would have right 4 and y-axis reflection. Now you might be thinking, why the heck does that matter? It has to do with the order of operations and how you would make a table to this and how you would graph this. And you would get a different answer. And I'll pull up Desmos here in just a second to show you if I do this. I'm going to show you both of those graphs here. I don't think I have Desmos up, so just pardon me. I want to use Desmos instead of my graphing calculator so that I can show you the 2 different equations in 2 different colors. I think it was that, and then it was to the 3rd power, and then it was this double parentheses x, oops, not x times 4, x minus 4 double the parentheses to the 3rd power. So you can see on the one where I did not separate them, the graph didn't move. Let's put the parent function there. The graph did not move to the right, right? It moved to the left. And we were supposed to move that graph to the right 4. So in order to move it to the right 4 and have it come out the way we wanted it, we have to separate those 2 equations or 2 transformations with the parentheses so they each happen by themselves. So you can see the horizontal reflection happened in both. They're both reversed and flipped, but the one that is red ended up going left, even though it has a minus sign there, and the one that is right, the blue one that went to the right 4, that's the one we were hoping to see. The reason is because, again, each thing needs to be identified separately. And so before I would identify what was happening here, I would ask you to factor out the GCF anyways. And that'll be kind of one thing we focus on a little bit further down the line. But just for now, keep in mind, if you have multiple transformations, this is a must. You must separate them by using parentheses for each individual one. Otherwise, you don't get what you're trying to get. Okay, not too many of that's going to happen today, but that's why we pointed out in the notes so we don't have to see it later. So why don't you think for a second, what's log 2 of x going to look like if I do all of these things? I'm going to give you I'm going to actually look at my watch and say, we're going to say 50 seconds to think about what's the equation look like, stretch 2, reflect y, write 4. And then I'll go over it. All right. I'm going to go through it one step at a time in case that's how you did it as well. So I'm going to say a vertical stretch would be 2 log base 2 of x. A vertical stretch with a y-axis reflection would be 2 log base 2 of negative x. And a vertical stretch y-axis reflection and write 4 ends up looking like that. So two different functions, but they have the same movements happening to them. All right, I got one more. We went from 3 equations with 2 things to 2 equations with 3 things. My last one is 1 equation and 5 different things. Okay, I'm going to say, give it a try, 50 seconds. All right, here we go. Horizontal compression by 3/2, if I'm referring with my notes. Horizontal compression is going to go inside, and this is the one where the reciprocal amount goes in the equation. So inside in an exponential function means it's going to happen up here in the exponent. So the 2 itself is just part of the equation. So when I put the reciprocal of 3/5 inside the equation, I have an exponent now of 5/3 x. Vertical compression by 3/5. Verticals, we don't switch those numbers at all, and they go outside. So this is going to go completely in front of what we have just written there. So it's going to be 3/5, and then that again. Right? Maybe put a multiplication sign in between the 2 of those. 3/5 times that. Reflection over the x-axis. When we do a reflection over the x-axis, that's going to go outside. So, oops, got a double 2 action there. So when I put a reflection over the x-axis, there's going to be a negative sign that goes outside. So now we have negative 3/5 times 2 to the 5/3 x power. Now we're going to go left 2. Okay, so let's take that whole thing. Left 2 has to go inside. Now we've got 2 things going on inside. So I'm going to add some parentheses here. Left is not minus, but it is plus. So now we have, as an exponent, 5/3 times the whole quantity, x plus 2. And then finally, let's throw in down 6. So we'll take everything that we've done so far and add to that down 6. So outside the function, we add negative 6. So my final answer would be y equals negative 3/5 times 2 raised to the power of 5/3 times the quantity x plus 2 minus 6. And that will do all of those 5 things that we were hoping for. So that's what I have for you. I am going to stay here and answer more questions that you have. I did just put a poll up there to see some responses about how you're feeling about this. So if before you disappear, if you have no questions, if you could please go over to that poll and respond to, this is really going bad. This is just a little bit better than bad. I'm starting to get a hang of this. I've got most of it, and I'm so confident I'm ready for the test. Okay. This poll is completely anonymous. It's just me getting a feel for where we're at. So once you voted, you are welcome to leave. I will hang out until the end of 5th hour. We got about 20 more minutes. If you want to ask more questions, or if you want to just start the homework and have me be here to check it, I would be happy to do that. Have a great day, my friends. Siri or Colin, do you guys have anything? Or are you just working and we'll just keep hanging out?